boxes mean that there has been a companies also, but they have not been succeeded to continue to this phase. And next, please, this was for the mobility side, and then for the energy side, sorry, yes, this one, yeah. So here we have quite many solutions which are dedicated for some kind of building management systems or something like that, and so that's the most popular one. It was in the first phase, but also in this second phase as well. So this is who you are, so you will let know each other. And if in the next slide, we have decided to our idea was and our purpose and target is to try to help you more than in the first phase, where there was quite many companies and not so much time either. So now we have decided to do so that we have named you a main contact city from our buyers group, who will be the main contact point for you, and they are also participating on those one-to-one meetings as well, or somebody from the cities. And here you see that how we have now divided you between the cities, and for those 3 companies in the energy lot, that's Symvio, Holoni, and Rebase, we have decided to do so that Amsterdam, Helsinki, and Stavanger, we are taking care of you together, because it was a little bit difficult because you have something similar in your mind, and we think that it's good, can be useful if you can be guided and discuss together some point. But then shortly about this kind of action and timeline overview for this starting phase. So it's already started, and now we are in the kickoff meeting, and soon as possible we start to organize those one-to-one meetings with you. So and on the November we are going to have a midterm checkup, and in the end of January, in practice, we are ending this phase, and what we are then expecting to get is to proven results or evidence that your solution can reduce the CO2 emissions, and how that AI is one key element on that solution also. And what we are definitely looking for is that how relevant the solution is for the cities, not only for these 6 cities that you are now working with, but also other cities, and the solution can be replicable in other places as well. And so this this kind of practical expected results are that there is a working prototype, what we have been discussing, and we would like to see also something working already in the November, so we can give you a little bit more and better feedback, perhaps, if we can see something what is how it works, or what are those features that you have been doing, and that this solution should be in the end of this project or this phase be demonstrated in a lab environment. And also together with you, we are of course asking that kind of roadmap for piloting and cost and so on, and business model, which can be also a little bit what we should also highlight a little bit, that those business models have to be so that also the cities can be the customers for your solution. because our understanding after this phase two tenders was that at least some of these are probably could work better with the consulting companies or something like that. But let's see, that's something that we can try to help you during this phase. And in this next slide is also that we have a lot of leaders. Martin Mobility from Tallinn and Petteri from Virium Helsinki is taking care of the energy lot, and they are also participating and contacting you for these meetings and practical questions you might have. And then we have been planning to have a regular meeting with each of you approximately every 2 weeks to give that kind of general and equal possibilities you to get the advices and feedback from the cities. And I have already invited you to the new Slack channel that for phase 2 suppliers workspace. And as already Jon mentioned in the beginning of this webinar, could you please add also your company or project name after your display name, so it's easier to know who you are and where are you coming from. And there you can send direct messages to us, but then there is always those official email addresses, that info which comes for me, and that communication email address which goes to the Jon in ICLEI. So that's very shortly what we have been planning, and those discussions and negotiations with you will start soon, and there we can get a good understanding your needs. So that's and on the in my last slide there is also the names of who are the contact points in the project part now, but they might be changed if we find and decide to have some dedicated person from the cities directly to you. But yes, let's move on the next topic, which I suppose is very interesting and hear. Yeah. What are you doing?
Thank you very much, Kaisa, for your presentation. And we will now continue to the suppliers. But before that, I also want to say good morning and welcome to the preferred partners, or to the people who from the group of preferred partners that we have in our call, who are, of course, also very much closely following the AI4Cities project. And yes, so we will now start with the presentations by the suppliers from the mobility lot. And we will start with Atmosphere. And who from Atmosphere is in this call and will present? Can you introduce yourself, please?
Yeah, hi, it's me. Can you hear me?
Yes, I can hear you. You have now sent me the presentation, and I will share my screen with let me check first. You can start introducing yourself.
Yeah, so hello everyone. My name is Carolina Seminario, and I'm part of the consortium composed of HOPU and engineering, and our project is called Atmosphere. So maybe I can start by saying that HOPU is a Spanish SME, and engineering is a larger company based in Italy. So maybe we can go to the slide 2. Or maybe can you make it a little bit bigger, please?
Yes.
Well, here you can see no, it's fine, thank you. Here you can see the team members, and you can see how we have divided us into three different teams. Next slide, please. So Atmosphere is a context-driven solution for mobility needs that uses business intelligence, data analytics, and is able to provide forecasts based on empiric models. With Atmosphere, we can identify what, where, and how the CO2 is produced. We can measure the impact of the different mitigation strategies, And we can do this while reducing human and economic resources. Next slide, please. How can we put this in a more tangible way? Atmosphere will lead to route flow optimization in road and canal or ports traffic, which is associated with a transfer from private vehicle, which can be a car or a vessel, to public transport, where we include all means, bus, underground, trains, e-scooters, everything. We do this through a context study of corrosive gas emissions, which are CO, NO2, etc., and weather, and through a behavior study, which includes the use, the demand and use of transport. We use artificial intelligence to develop some models in order to be able to create optimization plans based on data, like the placement of park and ride slots or low emission zones. Next slide, please. So our plans for phase 2 is prototyping. What we have learned so far is that the available databases are very complex. We have encountered some difficulties regarding language. For the prototyping, we need to proceed to the standardization and integration of all data sources. We need to convert them to proceed to the, we need to convert them into homogeneous ones to feed the artificial intelligence. We need to enhance interoperability. That means that we need to make them able to communicate with each other with the corresponding entry and exit formats, which is a big challenge. We need to continue developing the algorithms and check if the found data are enough or whether we might need more. And after processing all the data, we plan to start data modeling that will be able to result in different outputs, such as mobility and urban planning actions. Next slide, please. This is it. Thank you for your attention.
Yes, thank you very much for your presentation, Carolina. And to answer some questions in the chat, yes, you can send us the presentations and we will make them available on the website. And we will also, this webinar is being recorded. We will also publish the webinar on the website as well. Now, the next presentation is going to be by Avenue/Nomon, which we haven't received a presentation from. Can you introduce yourself if you are from that consortium?
Sure.
You can, yeah.
Hi, John. Thanks. I'm Diego. I'm from Populous and Richard Avenue. My colleague from Eeneman could not be here, so I think that's where the confusion was about the sending the presentation. I do have it. I don't know if I can share my screen or you prefer I just send it to you by email. Like 2 minutes ago.
Can you share the screen at the moment? Do you have this possibility? Then please do.
No, I don't actually.
No, you don't.
But I can walk you through it. And
you can walk me through it, and then you can send the presentation later on.
Sure,
after
of course.
The meeting. Yeah.
Yeah. So as I said, I am Diego Canales. I represent Populous. We're a winning team. So this is a team built of 2 companies. One is Eeneman and the other is Populous. Eeneman specializes in transport modeling and transport planning for transport systems, utilizing data that's non-typical. So for example, mobile devices, which they're called call detail records, so CDR, also smart car data, and they build models out of that. I am from Populous. We have a software tool that we collect and leverage data from shared mobility devices. And from that, we optimize certain type of policies, and then we communicate back those policies to either the cities, the operators, and also the mass providers. And we have a track record in working in many countries and many data points. Our solution would be built on merging 2 different type of tools. The one that we have, which is called Mobility Manager, which, as I said, Populous gets shared mobility data in a standardized way, and we also do user surveys of those operators. And the other one is Eeneman's Mobility Analytics, which uses mobile devices and public transport card data and other data sources. From that, we're going to build 3 different models, 3 modules that would be providing some outputs. So the 3 modules are demand prediction models to predict basically where the demand is happening. We're going to do GHG emission models that will be coupled with the prediction models. And from that, we're going to build a policy optimization that would be iterative based on the different inputs that we provide. We're going to be able to have 3 outputs, which will be mobility monitoring, the policy assessment, and the policy suggestions. So any suggestions or policy changes that the city wants to see, that will be reflected in the prediction model and the GHG emissions. And those will be communicated to 2 channels. One is an API service, and the other one will be a visualization and automatic. Yeah. And the automatic report generation. Really quick lessons learned from the phase one is that we have to take into account the vehicle life cycle of shared mobility devices. We want to make them sustainable. Cities in the EU are starting to work on shared mobility data collection. We're seeing a revamp of that, and they're asking for standardized data, which is really good, I think, for all players in the industry. We also have to estimate what is a proportion of mobility trips that are being captured from the public transport, walking, cycling, and how many for private vehicles. That is key for the GHG emissions. So basically the mode shift that's happening and how we change that to the policy optimization. And cities are not only interested in CO2 emissions, they want to see other environmental emissions, like, for example, NOxes or noise pollution. Our module, our phase two will be basically defining the low-level requirements, building the travel demand models, as I mentioned, that will be coupled with the GHG emissions. This is key. The policy optimization engine, and then putting that into a visual-friendly visualization tool and API that we communicate back to the, for example, the operators or the mass providers that will be taking that. Challenges, real quick, a lot of data sources. As I mentioned, we have shared mobility data. We also have mobile call detail records and what we call big data. So making sense of all that data will be challenging. And then I think you already addressed that, John, but like our key concern was to have feedback from cities when we're building the prototype. So whatever we produce basically resonates with them in terms of the tool that we built. And with that, thanks a lot for your time, and very happy to be part of this team.
Thank you very much, Diego. Next up is now Carto, who will present. Can you introduce yourself?
Hello, I'm Isabel from Carto. Do you have my presentation?
I have your presentation.
Okay.
I will now share my screen.
Great.
And let me, here it is.
Okay, thank you. So yeah, we are going to present Carto's solution for the mobility challenge of AI4Cities project. So next slide, please. So I'm here with my colleague Luis, which is project manager at Carto, and I am working the business strategy department. And our proposing solution is called Future Urban Mobility. So next slide, please. Yeah, so as you know, cities are under great pressure with more and more vehicles on the streets and more traffic congestion, which of course cause an increase in pollution and health issues to citizens. So micro and active mobility have a great potential to reduce CO2 emission and improve human health, as well as reduce traffic congestion and pressure on urban spaces and infrastructure. So both cities and citizens are clearly benefited from their increased use. But nonetheless, new shared micromobility modes are also challenging urban mobility planning due to their more fluid nature. So for instance, e-scooters have disrupted in many cities in Europe, blocking street sidewalks, creating a burden to pedestrians or interfering with other transport modes. So our vision is that it is required a real-time adaptive artificial intelligence tool to optimize its use in urban mobility. So next slide, please. Yes, so that is a Future Urban Mobility, which is a location intelligence solution that focuses on optimizing the incorporation of new shared mobility modes like micromobility or active mobility into urban planning, and at the same time monitors and predict the CO2 emission reduction. Next slide, please. So yes, our solution integrates artificial intelligence in the form of machine learning, and it has by 4 key steps. So the first one will be improving quality experience for users, adapting routes based on context analysis and the type of vehicles that they are using and their personal preference or requirements. Secondly, allowing gamification. So cities will be able to easily set up campaigns and challenges to their citizens to gamify the mobility experience. Also optimizing the organization of new micromobility modes by defining the optimal place to set up, for example, parking spaces, and understanding cities' mobility patterns. And finally, support decision-making based on the use of advanced predictive models for emission and air quality. So the next slide. Yes, so for phase 2, our goal will be developing a working prototype capable of being tested, so the cities and buyers group understand how the solution can be implemented and if it is relevant and meets all their requirements. And the main activities and also the main teams that from Carto that will be involved in this phase are the design team, then the data science for all the spatial data science work and the development of models, and software development, and finally, of course, testing activities. So that's all from my side. Thank you very much.
Thank you very much, Isabel. I am sorry there were some technical problems that didn't allow me to give the presentation in full screen, but people still could see it, I think, quite well. So then next is Franchet AI. Could you introduce yourself, please? Who is going to speak for Franchet AI? We have received the presentation from you.
I think her mic doesn't work. It's you, Ines, right?
Who is it?
Ines, I think.
Ines, okay. I will.
Now, no.
Now I can hear you. Yes. Wait. Please start. I will start. I will then share my screen. You're muted, Ines.
Do you hear me?
Yes. Can you see the screen now?
Can you hear me? No.
Yes, we can hear you.
Can you hear me?
Yes, we can.
Oh, and now, yeah.
We can hear you. Yes.
Okay, sorry, I can't hear you, but I'll try to present this way. I'm Ines from the Franchet AI project, absorbing traffic pollution with AI. Next slide, please. Franchet AI aims to reduce both the emission and concentration of CO2 and other greenhouse gases related to mobility by incentivizing sustainable and personalized travel behaviors while preserving data privacy and data control, by improving the experience to real-time and predictive data on green mobility solutions, and finally, by recommending locations for nature-based solutions such as Cartoonister Franchet plant, which was the inspiration for our project, and it's a super plant effective in absorbing traffic air pollution. So next slide, thank you. That being said, Franchet AI is an innovative data-driven and AI-based solution that aims at helping cities absorb traffic pollution. Our solution is powered by data from different providers, as you can see, and results in a dashboard for municipalities or transport operators and a mobile app for travelers. Next slide. Our team is composed of 3 cross-border and multidisciplinary companies, Ubiwhere from Portugal, 8wells from Cyprus, and Avista from Finland. Next slide. During the first phase, our team was able to do an exhaustive state-of-the-art and analysis of different models for greenhouse gas emissions estimation. We explored and trained different federated learning models for sensitive data. We carried out a deep analysis of data sets provided by the buyers group and other open data. And we also specified a machine learning pipeline for our solution. We foresee some challenges for the next phase, but we believe that the cities will be able to help us overcome them, namely by providing us with data so that we can train the models we are developing, and also in the stakeholders' engagement for participation and incentives. In the coming months, we have several ambitious goals. It's the same slide. We have several ambitious goals, namely, we aim to prototype a mobile application and web solution. We already have the mobile app mockups ready. We want to start the dissemination and community engagement. We want to validate the solution in a relevant environment. And finally, we intend to perform a go-to-market early validation. And that's it. Thank you for your time.
Thank you, Ines, very much. Can you hear me now? You cannot probably. Okay, then next up is Fronyx. Who is from Fronyx in the call?
Yeah, good morning here, Christopher.
Good morning, Christopher. I can hear you. Can you hear me?
Nice. Yeah, I can hear you as well.
Okay, then I will now start sharing. You can start talking and I will start sharing my presentation.
Cool. Thank you, John. Yeah, then good morning from my side, Christopher, from Fronyx. We are a AI startup from Germany, and we are working in the e-mobility industry. And if now my slides hopefully are coming, then you can directly go to the second slide actually, because that's the problem that we want to tackle in the AI4Cities project. That now, as many of you know, probably e-mobility is really growing heavily, and we have more and more cars on the streets, and the problem is always getting enough chargers on the street. And I personally also drive an electric vehicle, and sometimes I really struggle finding a vacant charge point. And here, for example, we see one location where almost every one of the chargers blocked, and I obviously don't want to queue there. And that's exactly what we want to solve in the project. Next slide. We teamed up with Energy. Energy is one of the bigger players in the industry, big charge point operator and e-mobility service provider. They have a charging application, as you can see there. And what we deliver them is a prediction when a charge point will be available in one of the cities of the AI4Cities buyer group. And we basically consider us as a AI as a service provider then to Energy, and want to pilot whether the drivers then have it easier to find a vacant charge point. Next slide. And what we did in phase one is we looked at these three components basically the whole solution has. The one is the data input, and we are quite confident that we in most of the cities we can deliver this AI. We can predict the charging behavior and the availability of charge points. We really can also scale that model to the size of the charging networks. The biggest one, for example, is in Amsterdam, and we are able to cover that with our solution. And we have some ideas and drafts for the front end, how then we can display the future availability to the drivers and help them making better decisions and finding free charge points. Next slide, please. And what we do now in the third phase is basically putting that, the second phase, sorry, I'm living in the future already. In the second phase, we are putting it all together, prototypically together with the Energy app. And there, we were looking forward to maybe have some EV drivers in the cities already that can play around with it and give us feedback to the front end and how they interact with that. And also we are open for any other potential integrations, city maps, parking maps, whatever, that can also maybe make use of our predictions. And what we also want to collaborate at is, with the traffic data, we played with the traffic data of Helsinki that is beneficial for our solution, and for the other cities where we're struggling and may want to look into that together with the cities, how we can get access to more data there. That's it. Thanks.
Thank you very much, Christopher. Next up is Insight Signals. Who from Insight Signals is in the call?
Good morning to all.
Good morning, Manuel.
Okay, I'm here. I'm very happy to be with you. And if you can put the slides.
I seem to have not received the slides from you, or I've missed it. Sorry.
All right, so let me share, because that's strange. Oh no, can I say, I'm sure you
I might have, I should have. Wait a minute. Yes. Yes, here they are. I am sorry, I had missed it.
That's okay. That's okay. Okay.
Yes, here they are.
Okay, perfect. So who are we? Basically, I'm Manuel Sela. I'm the founder of X9 Signals, which is a startup in the area of digital twins. Basically, what we do, we design and operate customer digital twins, which have the characteristics to focus on the behavior of consumer and users. So it can apply to cities, but it can apply to many other areas, which is consumer market, distribution, or whatever. Basically, what we want to do in that project is to build a user-centered mobility digital twin for the cities, which basically reproduces and simulates over time the transportation system of a city and calculate the resulting CO2 emissions. So basically, it gets a holistic view.
Thanks for your confidence and very happy to be part of AI4Cities Phase2. Who we are. So C-in.City stands for Carbon Intelligent City.
Hello?
To see.
Hello? Hello? Can you hear me?
Hello, I can hear you.
Yeah.
Someone else started talking suddenly. I am sorry.
That's okay.
Yeah.
So let me say, so a user-centered mobility digital twin, which reproduces and simulates over time the transportation system of a city and calculates the resulting CO2 emission. So which kind of sub-challenges are we addressing? I think we've put ourselves in out of the box in the sense that we will address a lot of the challenges in one way or another, but especially the three following challenges, which is to integrate mobility users' behavior into city investment decision, to increase project scaling and CO2 reduction through looking at the impact of a project on a digital twin, and at the end of the day, providing cities with a holistic view of how mobility choices contribute to the carbon neutrality goals. So that is our solution. And if you can lead me to the next slide, I will explain you what we've learned and what we plan to do. So what we've learned from phase one, we did a kind of a feasibility and market study, and we found there's a strong market resonance for digital twin, but at the same time, a quite immature view of what is a digital twin is about. Basically, some people have a set of heaters in the database spread across building, and this is called a digital twin. So there's a lot of definition of what is a digital twin is about, which means a lot of immaturity. We also found that there's the data available from one city to the other are very heterogeneous, and you've got some public data in one city which is not public in another one, etc. However, we also find from our phase one, and this is why we confirm we can do that project, is that there is a single cross-city mobility model, i.e. a generic mobility digital twin which could be applied to any city, which is feasible. And we've proven through our design, which is we have a digital twin that can be applied to any city. And last thing we've learned is something that we confirm, but we knew, but we confirm is that a digital twin doesn't reduce CO2 per se. A digital twin is a tool that helps CO2 reduction through better decision making or through helping other projects to better assess how much CO2 they reduce. So our plan for phase two are the following. Of course, we want to develop a working prototype of a mobility digital twin. This is our first and single most important objective. That's what we want to do. The second thing, we want to further explore how the prototype can be further implemented, replicated, and what is its replication potential. Basically, it's to dig further into its market potential. And the third thing, in order to do that, we need to refine the product that will come out of that prototype. The prototype is a technology, but the product that we will deliver to the city will be centered on the prototype, but will include other things in terms of services, product, and implementation methodology, and all of that. So this is what we plan to deliver for phase three, those three elements: prototype, further refinement on the market study, and a better definition of what we will actually provide and sell. So what our main challenge is, I think one of the main challenges we have now, but we will come quickly with an answer for that, is define what we will show by mid-November and what we will show by end of January, what will be available end of January. So we feel we've come already kind of an answer to that. Number two is to consolidate our market development strategy and how to convince cities to buy it. And the third thing, which is important, is that a digital twin needs to be interesting, to be focused at least on one example. So we need to have one city example, which means that the prototype will go together with some kind of we'll call first step implementation or first step piloting, because we'll need to include the specific data of one city. This is it. Thank you very much. This is it.
Thank you very much, Manuel. And I am sorry to whoever started speaking. We are a bit running later than expected. So it might have been that it was your time slot that in which you should have spoken, but we will continue now, and you will get your turn soon. And yes, as Petteri mentioned in the chat, you really should keep your presentations at the 3-minute minimum. So then, sorry. Next up is Kentyou. Who from Kentyou is in this call?
Hi, my name's Tim Ward, and I'll be presenting on behalf of Kentyou today.
Thank you very much.
I believe
Tim,
you should have some slides from us.
Yes, I have your slides. I am now going to share them.
Okay. So what I can start with is by saying a little bit about who Kentyou are. So we are a startup based in Grenoble, and we have expertise in IoT and data analytics, which we use in urban scenarios to help provide solutions for not only the city, but also the citizens. We're targeting the 3 sub-challenges, primarily the mobility as a service and traffic flow optimization. Oh, sorry, yeah, that slide was great. So we're looking to optimize the placement of soft mobility terminals. So these are things like either cycle racks, or if you have cycle hire terminals, or e-scooters, those sorts of things. And the traffic flow optimization is obviously monitoring roads, intersections, points of interest, identifying hotspots. And we actually not only collect live data, but we store data allowing for access to historic information. And the AI piece that we have is that not only can you effectively wind time backwards, you can also move forwards in time to see what the predicted situation is going to be over the next few hours or even days, and also analyze the impact of making a change to the system and how that will affect this prediction. For example, you may wish to close a particular road, or you may wish to make it a one-way, and you can see how that will impact the rest of the system. So if I could have the next slide, please. So in phase 1, we've done a lot of work with various different user groups. The primary focus we have is that actually not on data collection, which we're already pretty good at, but trying to make the best user experience for what it is that we've created. So you can see that we really are trying to make this a user-focused solution, where the cities are able to get a real understanding and insight from their data, rather than just collecting it and putting it into a vault from which it's rarely collected. So if I can have the next slide, please. So you can see here, this is part of the mock-up that we've produced. So it's things like these UI widgets to give you a really quick, immediate view of what it is that is happening right now, or what is predicted to happen in the near future. And also the introduction of a time slider to make it easier for people to access both history and predictions, and to move from real time into near real time or near future scenarios. So if I could have the next slide, please. Yes, so in phase 2, what we're going to be doing is prototyping and obviously providing user test environments, because one of the key parts of user experience is being able to get feedback from the users about not only what they want in the first place, but then also how you've implemented it. And this implementation will be obviously front-end components, but also back-end changes that are necessary to support this new front-end. And the key challenges are going to be making sure that we can get enough interaction with users from the city to do this testing, and also technically making sure that we maintain the scalability of the system, because if we're running in a scenario where there are thousands or tens of thousands of sensors, which is typical, then gathering this time-shifted data and being able to present it in real time is important and is going to be the thing that we need to make sure we can maintain within our system. So I believe that I've kept to my 3-minute time limit. If there are questions later, I'll be happy to answer them.
I think you have definitely keep your 3-minute time limit, and thank you very much for your presentation, Tim.
Yep.
So next up we have Gradient, and I am not sure if I have received a presentation from Gradient.
Hello, Jon. Yes, you have, and it's the iX3/MarshallAI.
That I received this morning. Maybe wait, let me.
Yep.
Wait, I have to find it now because. Yes, here it is.
All right, great. Yeah, so my name is Arttu Laitinen. I'm from I'm from MarshallAI, which is the other half of the iX3 consortium. So for this AI4Cities project, we have formed a team with Dunnik, which is a leading solution provider in traffic management systems in Europe and the world. And MarshallAI, our company, we are an expert in machine vision solutions, and we've done lots of deployments in the traffic area and the security scene. So what MarshallAI does is our systems identify objects in video feeds in real time, and this enables very sophisticated and very detailed data collection and data analysis, and of course automation. And the point of the iX3 solution is it's called intelligent interconnected intersections. So what we are going to do is we are improving traffic management logic by using dynamic inputs for traffic lights and in different intersections. And this is the main point here, is to add the capability of forming a very reliant and reliable real-time picture of what's happening in traffic and in different intersections, and then using this as a dynamic input for traffic management. And our main target is to get the traffic flows in cities to be more efficient. And well, the main sub-challenges we address relate to data analysis and data gathering for data planning, but also suboptimal usage of infrastructure and the lack of understanding the effects of changes in traffic light management logics and such. But this is, well, that's quite understandable. Next slide, please. What we did during phase 1 was we set up an intersection in Helsinki, which we used for data analysis, and we kind of like formed a baseline for what's going on in the traffic. And then we started planning these traffic management logic scenarios, which we are going to simulate during phase 2. And basically this will result in well, traffic management logic we can implement in the cities to achieve reductions in congestion and improve the traffic flow, and this reduces emissions. And then another big plan of phase 2 is to use the interconnectivity features. So basically we're going to use data from several different intersections in kind of like clustering it together and then making even more sophisticated traffic management choices automatically. But that's it, and thank you much.
Thank you very much, Arttu. Very nice presentation. Next up is Urban Radar.
Yes.
And I have also your presentation, which I will now start sharing quite soon. Here you go.
All right. So hi, everyone. My name is Hernan Mejia. I'm a product manager at Urban Radar. So first of all, who's Urban Radar? We are a team of mobility and technology practitioners, and we offer solutions to enable intuitive decision-making and planning for cities and industry. Our flagship platform, Insights, aggregates a wide variety of public and private data sources to offer intuitive but specialized geospatial analytics on mobility and urban planning. Next, please. At AI4Cities, we are tackling the challenge of optimization of logistics, expanding our portfolio of solutions and targeting structural inefficiencies in last mile logistics across Europe. City Forward, as we call it, is a digital forwarding agent that helps e-commerce retailers find cost-efficient delivery services for their products. Backstage, City Forward manages a virtual city logistics network, pulling resources from small logistics service providers, including vehicles, warehouses, and distribution centers, and uses a reinforcement learning core to continuously determine the optimal allocation of resources that minimizes costs and carbon emissions. Our approach is inspired and supported by the vision of the physical internet. Next, please. And by being at the center of urban logistics with City Forward, it not only provides value to retailers and shippers or logistics service providers, but also to cities who can better identify relevant environmental and social impacts and take policy actions to mitigate those impacts in their territory. Next one. For the project execution, Phase 1 meant a big step forward to refine the commercial, service, and technical feasibility of the solution, especially by refining the use cases we want to focus on. For Phase 2, we will have again 2 work streams. On the technical side, the focus is on refining and testing our current pool of optimization algorithms, since we have several algorithms right now chosen, and we plan to meet our criteria of computational cost, scalability, optimality, adaptability, and so on. And we will also prepare a front-end environment for the buyers group to explore and test the key aspects of the solution. On the commercial side, we will assess the pricing and overall business model while we strengthen our partnerships with the buyers group cities and other stakeholders. At the end of Phase 2, we will have settled with an AI method, and we will focus on commercial deployment during Phase 3, hopefully. That's all. Thank you so much. We can hear you.
Sorry, thank you, Hernan. We are now coming to the final presentation of the mobility lot, which is going to be Vianova.
Yes.
Can you? Yeah.
John, do you have my slides?
I have your slides, yes, and I will start sharing them now.
Good morning, everyone. My name is Alex Pezhkanix. I'm the head of policy at Vianova. We are a French company focused on shared mobility management through data management. We're working with our counterparts Rebel, a Dutch company focused on public transport, ticketing, and machine learning around public transport. The core crux of the solution that we're proposing, the mobility policy auto tuner, is the idea that if everything is a priority, nothing is a priority. And while CO2 emissions reduction is the chief goal of many cities, they're also working with competing objectives and priorities around, in particular, shared mobility management, public space management, equity and distribution of devices, pricing, and operational sustainability. So our solution focuses on allowing policymakers to articulate policy objectives and translating those into geospatial policies. Next slide. So the process begins with a policymaker setting targets and having assistance in weighting and scoring those priorities. again, to recognize that you simply can't optimize for every policy objective. Choices need to be made in order to sort of see outcomes, but then having a dynamic feedback loop as we see progress on those policies and whether or not the implementation of rules and regulations is actually leading to the desired policy outcomes. Next slide. We'll focus on a set of policy making built off of the existing CityScope platform that Vianova uses to manage shared mobility in a number of cities at the moment, but then offering enhanced features such as suggestions to modifications of these policies, whether spatial or temporal or pricing wise, and then tracking the contributions and the benefits of the policies. Next slide. The data will be a source of in-house data that's generated from various shared mobility operators, as well as existing data sources from in the phase 2 case, the buyers group cities, focused again on this question specifically around CO2 emission reduction. What is the potential of shared mobility to disrupt internal combustion engine vehicle trips, while at the same time avoiding cannibalization of other low carbon modes, such as walking or cycling. Next slide. Over the course of phase 2, we hope to do some significant improvements to the front end and user experience, recognizing that ultimately a big part of the value of machine learning and artificial intelligence will only come if policymakers actually adopt and use, as well as recognizing a number of other potential use cases beyond simply shared mobility management that have similar geospatial policy implications, such as goods delivery, ride-hail management, etc. Thank you.
Thank you very much, Alex. Yes, and now we have come to the end of the mobility lots, and we are running a bit late, but it is still good, I think, to have a 5-minute break because before we go to the energy lots. So I propose that we continue at 11 o'clock with B. Okay, I would now like to give the word to B, and I assume it's you, Michael Curtis, who is going to present this, or?
For the B consortium, I would present.
For B, yeah, sorry.
Yeah. Thanks. I would just share my screen. Maybe. Okay, I actually can't.
I will share the screen. Let me do it. Here you go.
Perfect. Thanks. Yeah, I'll try to keep it short. So we are the B consortium, which stands for Building Energy Efficiency. And if you could scroll down a little bit, we are a consortium of 3 partners, which is Eeneman, a smart energy company from Finland, which takes care of building integrations and controls. Unetic, a German artificial intelligence agency for sustainable projects, and the Metropolia University of Applied Sciences from Finland, which are working together in this project. We're also partnering with Platform of Trust, which does building integrations. Next slide, please, is our very high-level overview of our solution. So we're integrating into different building management systems with Platform of Trust, and we're trying to do 2 things. Basically, the first thing is shifting the energy usage within a building towards renewable energy, and then also we're trying to optimize the entire HVAC control within the building. Using Platform of Trust, we are having like a standardized interface in lots of different building management systems. And a key challenge that we found is actually that data is so different in different buildings. So we're having one data storage and control engine that offers us and our AI engine a standardized interface into different buildings. So our AI engine takes care of forecasting weather and also energy grid data, because we're relying on high quality energy grid data to forecast the carbon coefficient within the energy grid for the next day. And then when we know this carbon coefficient, we try to shift peak energy usage to times when there are a lot of renewables within the energy grid, like water heating, EV charging, or room cooling. The second thing that we're doing with our control is we're looking at the weather data and doing a forecast about the weather within the next day. And our AI engine learns automatically about the building itself, about how it will be used, how it will be occupied, how the thermal inertia between the outside and the inside of the building is, and how fast the building reacts to outside changes. Then we optimize the control of the building to be proactive. And for example, let's say if the outside temperature already rises, we can turn off the heating. By doing this energy shift and the optimized control, we estimate the 15% energy consumption reduction and a 15% energy emissions reduction that we can achieve and that we simulated in the first phase, which brings me to the next slide. With the building data that we already have from our case study building, which is at the Metropolia University. So what we learned in the first phase is that there's a lot of data, but it's very unstructured data, lots of different formats, languages that we actually need to tackle. So it is very crucial for us to bring all of this data in one unified standardized format, which we are on the one side tackling with Platform of Trust and our data integrations module, where we bring different data streams in one format to be for us to make it as easy as possible to integrate into different buildings. What we also learned is that there's actually a lot of savings potential with these 2 things that we do within the building, because buildings are quite inefficient nowadays though. For phase 2, I'll try to keep it short. So basically what we will do is we take our case study building, the Metropolia campus building in Helsinki, and we will build a first prototype of our product, train our AI on that building to learn everything, and test within a lab environment that our approach is working. So yeah, biggest challenges for us in this phase are obviously to build the prototype and integrate all the different data sources and design a scalable solution that is then in preparation for phase 3 makes it easy for us to integrate into all other buildings as well. That's already it. Thanks for listening.
Thank you very much, Lucas. Then we have next up is C.in.City. Can you introduce yourself?
Fuzi,
Fuzi, yeah, thank you.
Do you have my presentation?
I do have your presentation. I will now start sharing it. Here you go.
So thank you, John. So my name is Fuzi Ben Khalifa. I'm here on behalf of the C-in.City consortium. C-in.City stands for Carbon Intelligent City, and we are an alliance between 3 companies sharing the same vision. I will say translating climate science into impact-driven solution for city managers and businesses. So Keros brings its expertise to make the most of the satellite imageries in urban areas. Today, mostly these satellite imageries are used for forest, for oil and gas, for ocean, but very few usage for cities. La Javanaise is bringing its expertise to make the most of, and to develop AI-based service design. There are many references on this topic. And next, my company is making the bridge between the science community capabilities and the city needs. Next, please, next slide. So we aim to address a major challenge for climate action plan managers is the information gap. Why the spreadsheet-based tools were very relevant for awareness raising on city footprint and to help target settings. There's a growing discrepancy with the city needs for addressing the climate challenge. The time gap is now a very serious problem. We have at least 3 years delay between data sources and decision metrics, and this is no more possible. There's also very few and almost no possibility to feed the city GIS system with the existing self-reported inventory. And so today cities have only a spreadsheet and pie charts, no map for helping them in the action. And a very interesting point, city covers almost 70% of the CO2 emission in the world, but they only benefit from 1% of the carbon credit during the Kyoto Protocol. The main reason for this is that there is a problem for monitoring, reporting, verification of the urban project. And so the lack of information makes difficult access to climate finance. So our solution is mostly based on existing science pilot under the leadership of the World Meteorological Organization. 2 of these major products are embedded in our solution. The first one is Carbon Monitor with the LSE, a French laboratory, and the second one is Hestia, a fine granular GHG information system developed in the US. And so we'll try to feed them with near real-time activity data that we source from mostly unused space and ground data sets to deliver a 3-tier level service. First, having a good understanding of the ongoing situation thanks to carbon index and understanding what are the trends on the city. The third point is to have a nice picture of what are the potentials at the district level and in every sector, such as housing, mobility, industry, commercial, where are the low-hanging fruits. And the third level is at the building and street, where we can track the impact. So that's in a nutshell, our solution. Next. what we learned from the phase one, I will say, first, we consider that our service is dedicated not only to the city, but to all the urban stakeholders. So we launched several interviews with city managers, with NGOs, with citizens and businesses. And we launched this twofold process. In one hand, we try to understand the user needs through the interviews, and mostly they want something to go beyond only the GHG inventory. And the purpose for them is to increase the citizen buy-in through a carbon budget tracker, to assess the policy option with the what if and simulation tool, to target the best emission reduction opportunities with the climate decision metrics, and to unleash the possibility to access to climate finance. And so we have made also feasibility tests to see how this potential was really achievable in the city. And so we have seen a great scalability potential. And in fact, we have also a third process in parallel. We have been discussing with the GHG management tool community, such as the CDP, WBCSD, C40, and even ICLEI, and to see how we can introduce this near real-time data into their reporting framework. And that's something we can share maybe with the other awardees. Next. Next slide, please. Thanks. So I will be brief. So the big plan for phase two is to shift from the science product we are relying on to a really user-centered and impact-driven working prototype. And the main challenge is I think we share it with all the other consortium, is how to have a real involvement in the co-design and test with the users. Thanks.
Very much, Fouzi. We now need to make a bit of a change in our schedule because one company needs to go before 11:30. So I want to welcome Michael to give his presentation.
Hi guys.
Which company are you? Which solution do you represent, Michael?
Loopfront. And
Loopfront. Okay.
I sent you also the presentation.
You did. I will now share it. Yes.
Yes, and I will be very effective with the time.
Thank you. Here you go.
Great, thank you. Next slide. So our company is called Loopfront, and we are a B2B software as a service company from Norway. And we are creating the first circular management system for building owners. And our solution is we are providing a survey tool for our customers that allows them to collaborate and analyze their materials, that enables them to succeed with their circular processes in large organizations, for example, in Oslo municipality. And the sub-challenge we are addressing is the energy sub-challenge, and we are a wildcard. And what our goal is to increase the resource efficiency to reduce energy demand. Next slide, please. So what we learned from phase one of this project is that it's our first international project. And what we have learned is that we know now how to build processes by international standards, and also how to collaborate better with subcontractors who have expertise in AI technology, and also with better being able to understand how to handle unforeseen obstacles. Also, what we have learned from phase one is that the data deficiency proves the critical need for AI processes in an LCA context. Our plans for phase two is to be able to generate good data collection and integration of that data collection into our model, and then to create a CO2 prediction model for the reuse of materials, which then will be connected to our image recognition model. And our main challenge will be is basically time. We have made a very ambitious project for phase 2. So we will have a challenge with having a good speed of the data integration. Next slide, please.
That's all.
Oh yes, great. Thank you, guys.
Thank you very much, Michael, for keeping it so short. Now we resume our normal schedule again, and we go to Enerbrain as next. And we also do have Enerbrain slides. I will share them now, but you're welcome to start talking before I do that.
Thanks, John. Hi, everyone. I'm Alberto Riboni, International Sales Manager for Enerbrain. So as soon as you see our slides, you understand. Thanks. You can go to the next one. Enerbrain is an Italian company founded 6 years ago in Torino with a vision to make buildings sustainable in a simple and fast way, reducing pollution and increasing the saving of consumers. In the next slide, you'll see what Enerbrain system is in a nutshell. We're talking about a tailor-made monitoring system, collecting information and sending them to a cloud-based artificial intelligence system, which is analyzing them, sending back to a dynamic automation on HVAC system to optimize the production and to guarantee the comfort level required by our final users. All of that is accessible through an intuitive controlled dashboard, accessible in real time to our users through a simple browser. Please, if you can go on. These are the next slide, you'll see some of the main points that we can achieve. So at least 20% savings guaranteed to our user and to our customers, 90% of comfort time, a short time payback, so interesting for the investment, full access to a team of more than 60 energy experts based in Torino in Italy, full-time support service, user-friendly approach, and of course, the CO2 reduction, which is we are aiming for. Next, please. What are we doing for AI4Cities? Yeah, you can just keep this one, please, John. What we are developing is called Spike, a sustainable plug-and-play IoT kit for energy. As we all know, cities have to become energy communities, so controlling buildings automatically using the right amount of energy from the right source at the right time. Please. These are some of the sub-challenges that we addressed during our phase 1 work, let's say, so flexible energy consumption, energy efficiency, and development of renewable energies. Thanks, John. And this is some of the lessons learned from phase 1. So we understood that we need to let user interact with the Enerbrain platform through some specific APIs that we are going to develop in this phase 2. And we defined also the possibility to develop a new device to add to our collection. And in this case, it's going to be the e-wearable, a portable sensor for temperature, relative humidity, PM, and CO2 measuring. So something that people can carry around. Please. We also defined our project plan for the next 5 months. So starting now, September, going to end of January, we're starting with smart IoT device development, as I said. We're going to develop an innovative algorithm for energy management that's going to be equipped with deep reinforcement learning, the Spike platform development. And one interesting thing is that we are going to develop also a lab scale demonstration. Thanks. Some of the challenges that we are going to face in phase 2. Assessment of legacy device, because we are going to connect a lot of devices present in different buildings and different contexts. So we are going to develop a communication layer, develop ad hoc communication layer. So something that's going to be specific to allow these devices to communicate. And we know that we are going to need some important data collection, which are not always present, but we need to build this data collection to present a tailored CO2 reduction proposal. And in the end, as you can see in the next slide, which is normally the final one, this is what we can deliver: energy saving, scalability of our solution, and of course to target CO2 emission reduction. All of that available, of course, through a dashboard accessible every time in real time for our users. Thank you.
Thank you very much, Alberto. Next up is Heroes, I think. And
yes.
Good.
Thanks, John. Do you have our slides?
I have your slides. I just have a minor technical issue that I need to solve. I am sorry for this, but it will be just a minute.
Okay, no worries. Take your time. Good morning, everyone, in the first place.
Okay, here are your slides.
Yeah, there we go. So my name is Joshua, and together with my colleagues, we represent Heroes. And if you go a bit down, can you scroll down? Is that possible? Yeah. Well, to the mission. So at Heroes, it is our mission to coach organizations to become digital winners. And here we help them by building smart digital solutions using AI, but also other digital technologies like cloud or IoT. And then to introduce ourselves, there you see the heroes. Yeah, that one. So we're the main heroes that will be working on the prototyping phase. But whenever we need the superpowers of our fellow heroes, we'll be just go away to get their help. Then if you go to the next one, this is the solution that we propose, Building Connect, which is the building data cloud platform that aims at reducing the energy consumption of non-residential buildings and thus their CO2 footprint. And with Building Connect, we address the sub-challenges flexible energy consumption and energy efficiency, and more specifically, energy flexibility in buildings and optimizing energy usage of buildings and assets. And if you go to the next one. Yeah, finally, our learnings of phase 1 and our plan for phase 2. So during phase 1, we learned a lot about the feasibility of our solution. We did several experiments that showed promising results, indicating that our methods are effective for reducing the energy consumption of buildings. Furthermore, our plans for phase 2 are to make the solution design into reality and to create the building data cloud platform with all of its functionalities. And finally, we think that the main challenge will be to make sure that all the needs and requirements of the end users are satisfied. And in addition, streamlining data collection and ingestion process will probably also bring necessary difficulties, bringing us already to the end of our presentation.
Thank you very much, Joshua, and apologies for the inconvenience.
Yeah, no worries. Thank you.
Next up is Holoni, and I think that's the only company from the energy lot we haven't received slides from. Could it be the case?
John, I did send it early this morning, but I can also do it from my screen if you want.
No, but you cannot share it, unfortunately. I will try to find...
Check your mails.
Sorry, you can start and I will see if I can find the slides without the presentation, I mean.
Okay, very good. So my name is Wilfried Pimenta. I'm based in Oslo, and I'm the CEO of a venture builder called Alpha Venturi. We specialize in digital clean tech and emerging technologies. And we have teamed up as a consortium with Energinet, the grid transmission system operator in Denmark. And we have some subcontracted parties, including academia and deep tech providers. And together, we are developing a solution to enable positive energy districts and renewable energy communities, which is part of the scope of the cities going forward that is catalyzed by the EU Commission. And one of the key outcome of this is, of course, to reduce CO2 emissions by introducing more self-sufficiency and green energy deployment. Some of the sub-challenges we are tackling is to accelerate the mass scaling of rooftop solar across urban environments. and empower the citizens in particular to become prosumers. Our solution enables municipalities and local enterprise, for example, to source their energy from the local prosumers that have installed those solar panels. In addition, we verify the green origin of energy at the granular level. So at the 1 hour or less, there's an increasing challenge to make sure that we match in real time the actual gray energy from the green energy in order to ensure that this is really contributing to CO2 emission reduction. One of the outcomes is that it will increase the collective self-consumption. So not only individuals will contribute, but there's actually an efficiency gain as a community. We'll also explore future smart services around green balancing and citizen-centric business model that are an opportunity for the municipality services, but also enterprises. So the solution that you see here is decomposed in 3 steps. In AI4Cities, we focus a lot on the first one. Holoni Solar Surplus is an AI module that helps to predict the green energy surplus throughout a community. So if you have a district, different prosumers that want to feed energy to consumers, we are trying to evaluate, thanks to AI, what is the solar surplus. So not only the production potential, but also compare this towards with the consumption that they have. Because what we want is to leverage on the surplus so that a single prosumer can trade this surplus energy with the rest of the community. And so this is an AI module that is centered for AI4Cities, and this will be injected into a platform that is blockchain-based, which is a peer-to-peer energy trading platform. And in the context of AI4Cities, we're positioning a consumer that could be typically a municipality-owned building. It could be the city hall that decides to prove that it's purchasing electricity from its neighborhood and the local prosumers. In order to support this, so phase 2 plan, basically, we will have all those components coming a bit together in a minimal viable proof of concept. And AI is one of the important components. So we're looking at data access, combining open data, but Energinet, so the TSO in Denmark, has a key role to play because they will set up a sandbox for us to tap into all the data in Denmark that is relevant for us to simulate. And of course, we'll discuss with AI4Cities how we complement this with more data. We will train an AI module we call Holoni Solar Surplus, and we'll be able to apply different preferences. So if the municipality wants to say this building that we own will purchase electricity, we can play with the distance, the green origin, and different type of prosumers. And at the end of the game, we basically have a potential for energy surplus that will help catalyze the growth of energy communities. So this is us.
Okay, great. Thank you very much, Wilfried. Then next up, we have IBM Danmark. And we have received your slides, and I will be sharing them.
That's great. Thanks a lot. Thanks, and putting a great pressure on the last presentations. A great list of interesting solutions. So I hope you can all hear me loud and clear.
Yes, we can.
That's excellent. So we are represented by us, IBM Denmark to be specific, and we are a small entrepreneurial team working in the sustainability area, lifting a long heritage of strong deliverables and with a good impact to our society. So that's who we are, and we are a team that will deliver this. And our solution, it's called the Flex Planner tool, specifically for schools. And we are working within the flexibility market and the flexibility area, and thereby providing schools a tool for being able to measure and estimate the potential for flexibility, consumption flexibility they might have in their respective buildings, whether that might be the gym hall or the school facilities as such. And the sub-challenge we are addressing by delivering this tool is within the flexible energy area, and it's specific on the energy flexibility for buildings. thereby supporting the overall request for being able to provide solutions that can actually support the flexibility that is required for the green transition. So if you can turn to the next page, just to keep time, then I will just start. Jon, I'll just start speaking to that. Yeah, what we have learned, well, it's been a good learning experience, and one thing is for sure is that we've learned that we should stick to the template, so we've done that, and we have conceptually build a solution that has been pressure tested, and we still find it valid. So we haven't yet delivered any solutions or created any solutions as such, but that's what we're going to do now. And by learning, I think as well, we've been learned to be adaptive since during the phase one, we have as well had the instruction from the Energy Performance of Building Directive launching a great way to measure the smart readiness indicators for buildings, and thereby the ability to perform flexible consumption to the market as one thing, and energy optimization and other elements as well in this model. So we are incorporating that model. And talking about a model and as well linking to the last presentation where the Danish TSO was mentioned. So the market model has been launched, and the not only the Danish TSO but the Danish energy system is heavily depending on the flexibility service that are going to be requested for to support the transition. So our plans for phase two is to deliver the prototype and the lab testing where we will build and train the AI engine with the data from the schools. And it's to be built up in a way where we can successively train and add more and more data. So to the single administrator from the municipality or the school can start by having certain amount of data and then add more. We will, as mentioned, include the smart readiness indicators, and it's as well in a way where a school like me, so you might not have the full amount of data, but you can slowly build it up and thereby see how you compare to other schools that have been measured, and thereby see the overall potential for a building like you if you are supported with more smart technology. We will deliver by sprints, and that's not something we'll elaborate more about. So our main challenge is for sure is to get sufficient data. That's one thing, and the scope of the SRI, the smart readiness indicator, is still being conceptually new. I think we'll overcome that. That's just one of the challenges. And last but not least, the understanding of the flexibility and consumption flexibility is still difficult to grasp. So that's a major challenge for us as well to build that into our solution and make that easy to understand for the end users. Thank you very much.
Thank you very much, Thomas. Then next up we have Rebase, and I have also your presentation, so I will share it. But if you please first introduce yourself.
Yeah, hello everyone. My name is Sebastian. I'm the CEO and co-founder of Rebase. We're a digital energy startup based out of Stockholm, Sweden. And in this project, we're partnering with Grid Singularity, which is a startup based out of Berlin, Germany. So yes, this is us. So at Rebase, what we do is that we develop digital tools and APIs to help the energy innovators to plan and optimize distributed energy systems. And at Grid Singularity, they are developing a marketplace for energy to enable energy communities, as well as data and algorithm marketplace for sharing of analytics, basically in the energy space. So, and this we're doing to empower basically the end users and the cities to become partners and take part of the energy transition. Yes, you can go to the next slide. So basically, some learning from the first phase. So what we have learned is that energy modeling needs to be dynamic. So since the energy system is becoming more and more renewable and intermittent, we need to model the system hour by hour, or with even a higher frequency, dependent on the grid and also the market conditions. So that's a full requirement, and that's something that we've seen a lack of data sets that are providing that type of resolution. We have learned also that in the Nordic cities, we have heating as the main contributor to the CO2 emissions. So that's a focus point for sure, compared to a fairly already decarbonized grid. And lastly, that when sharing data, algorithms, information, it's very important with security and privacy that are taken very seriously in those aspects. Okay, so our plans ahead are basically that we have built a simulation model, which is based on a single building, and now we're going to scale it up to simulate and plan, optimize planning of distributed energy systems for not only one building, but also multiple buildings and communities. We're going to deploy an energy simulation for this energy community and run live virtual exchange of the grid singularity peer-to-peer energy trading platform that allows basically not only to optimize and develop energy AI models that trade and forecast and dispatch energy resources, but also to take in consideration the prosumer preferences of where and when energy is going to be traded. And lastly, some challenges ahead. So of course, it's also always data availability. Since we're working with energy communities, which is not fully kind of defined in terms of legal or regulatory aspects, there's still a lot of challenges there that we need to overcome and see what are the kind of workarounds that we can do. And of course, now even working deeper and more collaboratively and closer with the cities to understand how they can become our customer in the end, and how we can provide our solution to the city as a service provider after a complete project. And lastly, you can go to the last slide there. This is basically an illustration of what we're going to do in two phases. So one is more of an optimization, planning optimization of this distributed energy system, including the building portfolios. And the second one is a live exchange, basically running on the grid singularity platform. And both of these will be developed and showcased during this project. Thank you so much.
Thank you very much also, Sebastian. Yeah, then next up is Symvio. Can you introduce yourself if you are from Symvio, I'm sorry.
Hi, my name is Cedric. I'm one of the founders of Symvio. I'm not sure if you have our slides. I sent them quite late.
Here it is. Yeah.
So my name is Cedric. I'm one of the founders of Symvio. And what we do at Symvio is that we work with the facility managers, maintenance leaders, asset managers, and we help them have a better view on their equipment, their machines, so that they can run them in a more sustainable and an efficient way. In this project, if you go to the next slide, you'll see who we are here. So in this project, we work together with the Fraunhofer Institute for Solar Energy Systems in Germany, which is a leading research institute in energy transition topics. And we are working on this project on the next slide. What we're working on is district heating, because district heating is one of the key pillars of the decarbonization strategy of cities. But all the intelligence in district heating grids is upstream where the energy is being produced. But if we are going to add more buildings on the district heating, we're going to see for the need for intelligence downstream where the buildings are, where the users are. And this is what we are going to provide in this project. We're developing a solution for helping the operators of district heating networks understand this, in particular the substations better, and we're going to accompany them across the whole problem journey from generating, detecting problems, generating insights on how to react on these problems. If you move on to the next slide, or this slide is actually still fine. So what we are using in this project is a combination of different machine learning methods that we developed together with the Fraunhofer Institute and that are partially patented, which allow us to detect these problems in real time. And we also include feedback loops for continuous improvement of the methodology so that we can become better and better in the insights that we present to the operators. If you go to the next slide. So there you quickly see what we're going to do in phase 2. So in phase 2, we're really going to build this on a test setup that we have here. So we're going to combine the data that is already available in the cities that we learned about in phase 1 with an IoT device that we use to selectively get deeper insights on the district heating grid. We're going to analyze this and also communicate the insights. So we're going to demonstrate the full chain of our solution in phase 2. Quickly on what we learned in phase 1. So in phase 1, we learned a bit what the available data infrastructures in the cities that we're working with in this project actually is. We also learned about how they use digital technologies and their ambitions here. And also a very important aspect that we learned about in phase 1 was the organizational challenges with data within the cities. This is something that we were less aware of that we learned about in phase 1. The challenges that we are expecting in phase 2 are a bit what the others also mentioned. So integration of different data sources, especially here, we see a lot of different data qualities that we have to merge into one model. And another important aspect, just getting insights from users on the ground. These are the two things where we expect a bit of challenges. And that's it. Thank you.
Thank you very much, Cedric. And last, we have the Predictive Company. And I am sorry you had to wait this long, but it's finally your turn. And I think you shared the presentation with us this morning during the meeting. I will try to find it, but you can already start speaking.
Okay, thank you, John. Hi, everyone. I'm Jose Torres, a R&D technician from the Predictive Company. And our company is a spin-off of the Polytechnical University of Catalonia, and we work in close relationship with the MCIA UPC research group. So we're proposing a SaaS solution for energy efficiency based on AI, allowing to achieve energy savings and reductions of CO2 emissions to up to 30% in HVAC systems. The main sub-challenges that we are tackling inside the energy efficiency are the optimization energy usage of buildings and the assets of and the predictive maintenance. The next slide, please. Okay, now we go to the final slide.
Next slide, okay, yeah.
Yeah. So what have we learned from the phase 1? Firstly, we have two main point of view, the tech side and the business side. From the tech side, the technical approach, we learn about new configurations and HVAC systems and how to adapt our solution to them. Firstly, because of the district heating mostly applied solution in I think 3 of the 5 cities, and also the different types of acquisition of information inside of all of the cities. In the business plan, we learned that we needed to do a business model more B2G-like and simplify it and put it kind of more attractive for the cities. Besides that, due to the competitiveness of the call, we were encouraged to reanalyze our added value and understand better the good size of our proposal and make them visible. So what are our plans for the phase 2? And in short terms are acquire more real data, create simulations, and create a plan phase for phase 3. And why is that? Because our main issue or our main challenge is the data acquisition, since we have quite different types of databases from we can acquire information. And the work not only depends from us, even from the city side. So this kind of communication, I think, is the more challenging part of the project. So this is it in 3 words, I think.
Yes, thank you very much, Jose. And yeah, I apologize for running half an hour over time in this webinar, but it was very inspiring to see all your presentations, and you all have clearly very interesting and very innovative ideas that will be very interesting to communicate about in the next few months. And it was, I think, also very valuable that you shared the lessons you've learned from phase one. Those are not just valuable for you, but I think also for other companies and other organizations working in the similar sector. And yes, so we will be adding the presentation slides to the website very soon. We will also add the recording of this Zoom webinar very soon. And yes, I will also get back to you in the next week with some communication materials that you can use to communicate your presence in phase two and your participation in this project. And for the rest, I will give now the word to Kaisa to maybe say some final words.
Yes, thank you all of you. It was really interesting and valuable for us to see and hear about you. Well, we have so late, so I don't spend more time, but I would like to just say thank you for participating and welcome. And we are going to send you the feedback from the reviewers quite soon. They are now prepared and we can send them to you. So thank you and have a nice day and weekend. Thank you. Bye-bye.
Thank you very much. Bye-bye.
Thanks. Bye, everyone.
Bye.
Bye.
Thanks. Bye, everyone.
Thank you. Bye.
Thanks, everyone. Bye.